In this section, we will create the alarm that will be triggered when we are detected. So we will create its blueprint, add its logic and sounds, and we will also make two types of sensors, a rotative sensor and a bar sensor. So let's get started. In this lecture, we will begin to create the sensors and alarm system, creating the alarm blueprint. So let's get started. Alright, so what we're going to do is go into the content browser, open up the blueprints folder, and right click and create a new folder. Let's call this sensors _ alarms. So in here is where we are going to be placing all of our blueprints, because we're going to have multiple ones under our sensors and alarm system. So let's begin creating our alarm. So right click and create a new blueprint class. In this case, we are going to be creating an actor class. This because it will just be an actor that will be placed in the world, and it's exactly what we need. So let's select this and let's call this BP_alarm. Let's go ahead and open up the blueprint. So this alarm will be placed in a world and will be activated by our sensors later on. But for now, let's go ahead and create the basic functionality of just spinning and making sounds when it's activated. So let's go back into the blueprint. As you can see, we're going to go into the viewport and start adding a component. Now this is just temporary, but for now what we're going to do is add a cylinder. And this is just to have a model of it. I am going to scale down this cylinder, so let me just drag it into the scene to see its scale compared to the other actors in the world. As you can see right now, it is pretty big, so let's make it a bit smaller. So what we're going to do is lock the scale and put this to be around let's do 0.5. And as you can see, it's way smaller and I like it a bit more. So alarm will be right now over here with this size. So what we're going to do right now is add two more things. So inside the cylinder, so basically with the cylinder selected, we are going to add a spotlight. And this because we are going to have two lights spinning. So the first spotlight will be under the cylinder, and then what we can do is just move a bit the spotlight so it's outside, because now it will be inside the cylinder and it will not display the light properly, of course. So now what we're going to do is change the light color to be reddish, and then we can put the intensity to be into the max. Now we can play with the angle and so on in a second, but let's duplicate this, and this will be the spotlight 2. And we're gonna go ahead and just rotate this exactly 180 degrees, and let's move it into the other side. So now we will have two exact spotlights that will be spinning. Now for them to spin, what we can do is add a component, and this will be the rotating movement component. As you can see right now, the rotation rate will be 180 in the z-axis. Let's go ahead and put around 200, so it's a bit faster. Now, in order to showcase this a bit better, what I am going to do is inside the cylinder, just add a box. Now you don't have to do this, but I'm just going to showcase how this movement will work. And as you can see, I'm going to place this here, and this is just to see this box spinning. So now if I were to press Alt S, you can simulate the game. As you can see, now we have our alarm spinning with our spotlights and the cube that I just added. Now the cube is just temporary to showcase this, so I can just delete it. But as you can see, our spotlights are spinning and so on, and it's really looking pretty cool. So let's go into the event graph and start to add our logic. In this case, let's delete all of the default custom events, and we're going to create a new event. So just right click in our graph and type in custom event, and now we can create a new one. This will be start alarm. So basically, later on, when our sensors will detect our player, they will call this start alarm event in the alarm. So what we need to do right now is create a new variable, and this will be alarm active. So what we're going to do is drag it and get it and add a not boolean node, and this is just making sure that our alarm is not active. If so, we're gonna make a branch. This is like an if condition. So if this is true, it will go through here, and if this is false, it will go through here. So in this case, if our alarm is not active, it will go through the true statement, because we're doing the opposite here basically. So in this case, what we want to do is make this node, which is spawn sound at location. as you can see. So in here we'll basically display a sound. In this case, we will need to import our custom alarm sound, which is what we're going to do. But just for a test over here, I am going to select this fire sound, okay? Which is just like this. So let me use a play. And don't worry, in a second we'll import the correct one. And now the location, well, the location which will, this sound spawn will be our get actor location. So we can put it in exactly where we are right now in the scene. Well, in this case, where the alarm is right now in the scene. Now let's save this sound as a variable, so later on we can control it, change the volume, and so on. So just right click, promote this output, and now this will be our alarm sound. And then after this, what we can do is get our alarm active and set it to be true. Great. So with that said, this will start our sound, so we can test this. Now, of course, right now we need to call our start alarm. So just to demonstrate this, what I'm gonna do is just add the begin play. So when the game starts, I'm gonna add a small delay. So let's wait like 3 seconds, and then I will call start alarm. And of course, this is just temporary, just to showcase this. So now if I were to simulate, as you can see, I will wait 3 seconds, and the sound starts appearing. Right now it's this ugly fire sound, but let's go ahead and import our actual alarm sound. Okay, so let's import our sounds. So let's go into the content browser, just right click, new folder, and just name it audio. So here's where I'm gonna be importing all the audio, so everything is neat. Let's also create a subfolder called, just alarms, I think will be better. So alarms, and now we can import our two sounds. So, okay, while I can't distribute the sound files myself, I'll leave a URL link in the lecture notes to the sounds that I've chosen. I used freesound.org for the sounds, but you can use whatever sound effects sound good to you. I recommend freesound.org, opengameart.org, or even the marketplace. If for whatever reason the sounds I've linked are no longer available sometime in the future while you're watching the course, no worries, just take some time and find some other sound effects that sounds good to you. And once you have chosen your files, or the ones that you've chosen, or the same ones as me, what I want to do is select both of them, is drag them into the Unreal Engine, and then you can see that I have imported them. So let's quickly just double click on them and just make sure to enable looping in both of them. So there we go. So they'll just loop, and then what we can do is to play both of them at the same time, but not start to create two spawn sound at location nodes. What we can do is right click, go into audio, and create a meta sound source. Let's name this ms_alarm, and let's open this up. So as you can see, this is a whole new thing. It's like a blueprint, but it's not a blueprint. It's like a blueprint for audio. So let me just showcase the basics. We have the input, output, okay? In terms of output of the audio itself that comes out, and output on timing, so when the audio has finished playing. So what we're going to do is get the input node, just drag it, and now in here we can type play wave player. In this case it will be mono, and we can now just play a sound. It's like we're calling this spawn sound node, okay? But instead of that, we're just using this one in the meta sound. In this case, this will be our alarm master, and make sure loop is on. And now what we can do is put this on finished, and we can put our output mono on here. So now if we press play, you can hear the alarm sound. But what we're going to do is also get one from here and do another wave player, mono once again, very important. And here this time it will be our siren. And then the thing is that because we kind of put two outputs in one, we have to create a mixer. So if we just make this node, and it'll be a mono mixer of two. So now this output will be this one, and now this output will be here. So basically this will just join both outputs into two inputs, which will just give us one output. I love outputs and inputs, but it is what it is. It's just making everything just combine into one. So now you can see when I press play, both of them play at the same time. Let's make sure that loop is ticked on. So now in our alarm, we can just select our MS alarm that we created, and now that will play instead. Now let's quickly just go ahead and create one more thing. So right click, go into audio, and we're gonna go into spatialization and create a sound attenuation. This will basically allow our audio to play in 3D. So let's name this SA_alarm. Let's open this up, and now basically this will be the inner radius. So how far away from the player it will be playing in 2D. In this case, we're gonna leave it at 400. By default, distance is basically the max distance that our player will be able to hear the audio. In this case, we are also gonna be limiting this as default. So now we can just save, go back into our meta sound, and now go into the source section. Just go into attenuation and plug in our alarm. So this asset will just convert this to be in a 3D sound. If I were now to drag it, so you can see we have a preview of the gizmo. So this is the minimum area. So in here we'll be able to hear in 2D, and then in the other area, as we get away from it, we'll start to hear it less. So make sure to delete that, and now we can use press play, and after 2 seconds it will be playing. And as I zoom out, as you can see, the audio disappears. Zoom in, and as you can see, the audio basically stopped when I went out of the max distance and just returned back. And this is because we have to do a quick change. So let's go into the meta sound alarm. We're gonna go and click the source settings, and now in voice management, in virtualization, we're gonna change the mode to be play when silent. So now it will not restart, because before it was in restart. So now you will see that when I go ahead and press this and go here, press playing, and go out of the thing, and then go back, and it will still go ahead and carry play. So that's what we got right now here. Okay, so here comes today's lecture challenge. So you need to create a custom event to stop the alarm. It will be a similar thing to what we did with the start alarm, but the inverted concept. So here are some hints. You can use branches to make sure the alarm is active, so only stop the alarm when it's actually active, and use the fade out node from the alarm sound variable, and etc. So pause the video, give it a go, and in some seconds we'll quickly go ahead and cover that. Welcome back. So let's create this new custom event which will stop the alarm, and in this case this will just go ahead and make sure that our alarm is active. It's always very important to make sure that our conditions are good to avoid errors. And then if so, what we're going to do is get our alarm sound that we created earlier and just fade it out. And with that said, we can put, like, for example, 1 second to fade out, and that's it. I will just make sure everything's active, and now also set alarm active to be disabled. So now it's false. So now that will be great for us, and there we go. That will be for this first lecture. In the next lecture, we'll be continuing with the alarm, so finishing off some retouches and then starting off with the next sensor. So see ya in the next lecture. In this lecture, we will be creating the parent sensor blueprint, so let's get started. So this parent sensor blueprint will have the logic and with the event to call the alarm when a player has been detected. So let's go into the blueprints folder, open up our sensors and alarms folder, and let's right click and create a new blueprint class. In this case, once again, it will be an actor as we want to place it in the scene. This will be BP_sensor. So now we can go ahead and open up this blueprint. So this blueprint will be the parent of all the sensor models that we'll have later on. So this will not really contain any heavy logic or even any components or so on. It will only really contain 2 things, which is gonna be, first of all, a point light, and this is because all the sensors will have this point light which will like flicker when a sensor has been detected, and because we want to apply it to all sensors, it makes sense to have it in the parent. So in this case, we're gonna change the light color to be like a reddish, and then I'm gonna put the intensity to be in the top, so max intensity over there. Then what we're going to do is go into the event graph, and we are going to be deleting all the custom events that are by default, and let's right click and create our own custom event. So I just type custom event, and down here we are going to call this detect player. So what we're going to do is add an input into this custom event. So later on, when a sensor will call this parent event, we can pass in a value. In this case, it will be the actor detected. So this actor detected will be of type actor. In this case, you can see that we have a whole bunch of them. So it will be in this actor types. The first one, which is just the standard actor, it will be an object reference, the blue one. So now what we're going to do is make sure that this actor that has been detected is indeed the player. So what we can do is drag this over here and get this node, which is the has tag. And on here, we can type in player. Now this has to be exactly the same as the one that we're going to be applying right now into our player blueprint. So make sure to type it just like this without any spaces or whatsoever. So now let's go into our player blueprint, which is our BP robber, and let's add this tag. So what we can do is go into the class defaults and in the details panel, search for tag, and we want to apply an actor tag, which is just one that will affect the whole blueprint. We do not want to add a specific tag to a component. It's going to be for the whole blueprint itself. So let's add one. It's going to be player, and once again, it has to be exactly the same cases, same spaces, exactly the same. If not, it will not work. So now we can compile, save, and close. So with this, what we can do is add a branch. So if it's the player, it will continue. Now let's also just control one more thing, and it's that this sensor has already been fired or not. So let's go into variables, create a new variable, and be has detected. So by default, it will be false. And on here, let's go ahead and get this and then say not Boolean. So if this is not true, we can go ahead and detect, because basically we don't want to detect the player 2 times. It will not make any sense. So let's go ahead and drag this and make an and Boolean node, as you can see. So we can apply 2 conditions. In this case, let's move this pin down. So by holding control, we can go ahead and drag it down. And then also let's hold control and move it into this pin and put it here. So now this branch will only go ahead and succeed if these 2 statements are true. So now what we can do is go and get has detected and set it to be, of course, true. And what we can do is also play a sound at the location. The sound will be this camera shutter, which will be included in the starter content as we included when we created the third-person template. Now the the sound location will be in this actor. So we can say get actor location. And then what we are going to do is basically create a sound attenuation. So a sound attenuation will allow us to make the sound in a 3D space. So let's go here into content, audio, and inside alarms, we already have a sound attenuation that we created before, but this time we're going to create one which is a bit smaller, only for the sensors. So what we can do is select it, Ctrl D to duplicate it, and change the name to be SA sensor. Let's open this up, and this will be way smaller. So first of all, the inner radius will be around 120, and the max one will be around 1500. We can play around with the values a bit later. So now what we can do is apply this attenuation into the one here, and now it will play that sound and so on when we detect our player. Great. So what we want to do right now is go ahead and activate our alarm. So let's go ahead and do so. Say get actor of class. So basically this node will search through the whole actors of our level. So basically through the whole outliner basically, and find the one that we need. In this case, it will be finding our BP underscore alarm. Now, this node is pretty, performance heavy. So I recommend to not really use it a lot. But in this case, because we are only going to be having one alarm in the whole level, and this event will only be triggered when it detects the player, which won't be very often, well, in that case, we can go ahead and allow us to use it. But make sure that, you use this being careful, okay? One thing I want to point out is that if for some reason there are no alarms in the level, and it returns an empty object reference, which is just similar to a null pointer in C++, it can lead to a crash. And I know that this is unlikely to happen because we have, an alarm yes or yes in the level, but imagine that we don't have, well, it could lead to a crash. So we can also, use the is valid node just to make sure. In our case, we won't need it, but I just wanted to let you know. So with that said, what we can do is call the start alarm event. Great. So with that said, it will go ahead and detect the player and so on. Now let's do one last thing, that is basically to flash this point light that we created earlier. Now by default, let's make the intensity 0 because it will be like disabled, and this will just flash real quick and then hide once we have detected. So what we can do is go ahead and drag this and add a timeline. So a timeline will allow us to transition between values through time. In this case, we can call this the whatever point light timeline. It doesn't really matter how we call it. And then what we can do is double click this and create a new float track. So this float track will be the output that it gives. In this case, it will be the intensity of our light. So first of all, let's put a length for this time that will happen. In this case, it's gonna be very quick, so 0.2 seconds. So now what we can do is right click and add a key. In this case, the first key will be when the time is 0 and the value is 0. But the second key will be when the time is 0.1 because it will be basically in the middle, and the value will be when it's 1. So it will be through the whole point. Now let's add another key, so right click, add another key, and this time it will be at 0.2, so when it has finished the time, but the value back to 0. So it will go flash right intensity and then go back down to being, without any light. So with that said, this will give us the output. So what we can do is lerp, and this will lerp in a float, so between two values. In this case, let's hold control and move our A into alpha, so it will basically transition between the value in A and B over this alpha, which will happen over time. So what we're going to do is place our light intensity. In this case, A will be 0, and then the max one will be basically this large number. So what we're going to do is just go ahead and copy and paste it. It will just save us time. Let's go back and put this to 0, and now what we can do is get this point light, set intensity, and then just go in the update and plug it in, and this will go ahead and perfectly work. So there we go. We're gonna leave it like this, and that will be it for this lecture because we have the parent set up. So in the next lecture, we will be creating the first sensor model, which will be a child from this, and it will be this rotative sensor that will be placed in here, and it will detect when the player goes through. So see ya in the next lecture. In this lecture, we will be setting up the first sensor type, which will be this rotative sensor. So let's get started. Alright, so let's go into our blueprint folder, sensors and alarms folder. As you can see, in the last lecture, we created this BP sensor, which will be our parent. So now what we need to do is create a child from this blueprint. Now there are two ways of doing this. The first way is just right click, create a new blueprint class, and now what we can do is expand this into all classes and manually search our BP underscore sensor that we created, and we can create a child from this class. But an easier way will be just to select our BP sensor, right click, and then say create child blueprint class. So I'm gonna be choosing this one. As you can see, it has already named this appropriately. So BP underscore sensor underscore child. In this case, we're gonna say BP underscore sensor underscore rotative. And let's go ahead and open up this blueprint. As you can see, it already contains our point light, and the logic will not appear, but at any time I can just go ahead and call my detect player event that we created earlier. Okay, so you can see the code will be like behind the scenes. So let's go ahead and select everything, go ahead and delete this, and let's go into viewport and start adding some components so we can go ahead and start having some 3D meshes, and we can start seeing our head rotate and so on. So let's go ahead and add a new component, and in this case it will be a sphere. So it'll be a simple sphere, and I'm gonna call this the head. Now let's change the scale of this sphere to be smaller. So let's go ahead and lock it and change this to be around 0.4, and now this will be way smaller. Now another thing I'm going to do is select and change this material. Let's put it to be just green for now. Now this model is temporary. We are actually going to be importing a actual sensor model in the few next lectures, so don't worry about this, but just to get going. Okay, Now for this, what we're going to do is indicate where the sensor is looking, because right now it's just a sphere. So with this head selected, I can just add a cube over here. Now let's go ahead and change this to be the front of our thing, and then we can change the scale to be on 0.2. But then what we can do is unlock it, and for our y-axis gonna be 7. So well, actually 7 will be a bit big, but you can put, for example, let's say, yeah, 0.7. That was what I was meaning. So now what we can do is just put a bit forward, and as you can see now we have this kind of sunglasses, I guess you could say, for our sensor, so we can see where it is aiming right now, which is very important for us. Now let's go ahead and select again the head, and what we are going to be adding is a spotlight. Okay, so this spotlight will be our main thing to identify this rotative sensor. So again, let's select the color and put it all red, and let's go ahead and max out the intensity. So what I'm going to do is also rotate this a bit. So let's go ahead and select the rotative tool, and let's put it to be around 10 degrees. So now I can just rotate it around, let's do minus 30 degrees and leave it there. So basically this will create a spotlight, and that will be able to see in our level. So if I were to compile, go here and drag in my rotative sensor, I can just put it in this corner and rotate it to be facing this way. As you can see, we have this light. Now this light will not really be visible, but the thing is, a bit later on we will be creating this volumetric material which will enhance this spotlight, which will make it more visible. So this will basically result in this 3D effect of, but we can see the area of our sensor. Okay, so you see as we get going, but for now we're going to be living as this spotlight. Now what we're going to do is, as a child of the spotlight, is create a static mesh, and this will be the trigger detection zone. Of course I'm typing in all caps. Detection zone, there we go. So this trigger detection zone will be a huge cone that will basically later on be applied with this volumetric material that I just mentioned, and also it will act as a trigger itself, so it will detect that collision for our player. So in this case, let's apply a cone, and then you can see they have two cones. We're going to apply the first one, it doesn't really matter, and then what we're going to do is rotative with these same as our spotlight, which in this case we can just lock it to be in here, and then just rotate it to be around 80 degrees, and then we can just put a bit down, and you can see it's already illuminated by our spotlight, but don't worry about that. And let's lock this scale and make it big. Now let's find a value that suits us. Maybe I think 5 will work for us, so we can just put it down like this, and you can see that all this trigger will be acting as our detective zone. So there we go. Now right now what we're going to do is go down and change the collision preset. Right now it's set as block all dynamic, which will stop the player from going. We want to change this to be overlap all, which will mean that our player can go through, but it will still detect the objects coming in and out of this trigger basically. Now for now, let's go and basically apply another material. So what we're going to do is create a new material, and this will be temporary. Like I mentioned before, we're going to be creating this volumetric one, but for now let's just go right now into the root content. We'll put it up into another materials folder in a second, but just right click, create a material. This will be m underscore detection zone. Let's open this up, and like I said, this is just temporary, so you can see this is the material. We have the output here with different nodes. So what we can do is hold the 3 key in our keyboard and then left click, and this will create a new node which we can apply into a color. In this case, let's double click this, put it red, and pass it into our base color. This will give, like you may notice, the base color. So also let's put it in the other pin. There we go. Now it's red. And now what we need to do is just select this output node. I'm going to change the blend mode from being opaque to translucent. And so this will allow us to have some transparency. In this case, we're going to go ahead and hold the 1 key and then left click. This will just create a simple float node. So I can just pass it into the opacity and let's put like 0.3. And this will make it a bit visible, as you can see. So you can just apply, go here and apply this arrow into this here. So you can see we have this trigger detective zone, and we can press play, and we can go through it. As you can see, right now this is temporary. Also, one thing that just happened is that, of course, we haven't applied the logic to be detecting and calling the alarm. That's in the parent but not in the child. So let's select the alarm. So what we can do is just go and select it in the world, Control E, and we'll open up the blueprint. And let's remove this begin play that we did for the testing because it was just, sounding a lot. Okay, so now that we have this rotating sensor there, what we can do is select the trigger detection zone, go down, and add an event in the on component begin overlap. And this is basically when an actor enters into this zone. Okay, so here's the challenge. You need to call the detect player event that we created in the parent in the on component begin overlap. You need to reference the actor that has been detected. In this case, it will be the other actor output that we got on the begin overlap. With that said, pause the video, give it a go, and in some seconds, we'll cover that. Welcome back. So what we are going to do is drag the connection. And because this is a child of our BP sensor, we can go ahead and call the detect player node. And here what we can do is leave the first one as target itself, but the actor detected, this will be other actor. And this is the actor that has been going through that trigger. So as you can see right now, we can go ahead and test this. We can go through the detection zone. As you can see, it will flash with a light and it will start to activate the alarm. So everything is going ahead and working, so that is great. So let's go ahead and make the last thing, which is make this rotative sensor actually rotate back and forth over there. So let's quickly just go into the sensor rotative. I'm going to do is go up here and add a begin play node, because we want to do this when the game starts and it will just be in a loop. So once again, we are going to be creating a timeline. So let's go ahead and call the add timeline node, and this will be motion. So on here, what we can do is open up this node. So yeah, this node timeline, and we can add once again a float track because we want to transition between floats. In this case, this will be the rotation, and basically the length will depend on what you want, but 5 will work great for me. So we're gonna right click, add a new key, and this will be the first key. In this case, our time will be 0 and value 0. So that will be the first rotation. Then it will go and add a new key into the time, which it will be until the end, which is 5, and then the value will be 1. So now if I click these 2 buttons, I can adjust my time, and you can see over time it will go ahead and move from this rotation into this rotation. And then what we can do later on is invert this rotation to go back. So that's what we're going to be doing. So let's go back into our event graph, and on here what we're going to do is in the update, get the head and set the relative rotation. So the relative rotation as the difference between the world rotation is the one in the blueprint. So this specific rotation here, for example, 30 degrees here, right? That's the relative rotation, not the one in our scene, in our world. So that said, let's go ahead and just move it up so we have a bit more space. And then what we're going to do is get this rotation and do a lerp, but this time instead of being just a float, it will be a lerp rotator, because this will transition with this alpha between these two values in here. In this case, what we want to do is in the z-axis, apply 90 degrees over here. So it will begin looking this way. And then what I want to do is end up with minus 90 degrees. So end up looping this way. So it will basically do this 180 degree thing. So let's go back, set this back to 0, go to the event graph, put here 90, and then here minus 90. With our lerp node set up, let's take our return value and plug that into our new rotation. So we can go ahead and test this, play. You can see it will be rotating, but there's a problem. It will reach the end and then it will not do anything. So what we can do is basically when it's finished, go and do a flip flop. Okay, so it's gonna be a very interesting thing that we're going to do right now. So you can see the flip flop will be this node, which will give us 2 outputs. So the first time an input goes here, it will go through A, and then the second time an input goes here, it will go to B. So we can use this for basically looping this. So once this motion has finished, what we can do is now do the reverse, because it will now go back into its point. So what we can do to organize this is just double click in this pin and just move it a bit down. double click, and move it a bit down over here. Okay, so this will basically go and do the reverse when the loop has finished. But then the second time, we want to now go back and play from the start. So we'll resume. So we can just get the B, put it into play. Now double click once again, put it up, double click once again, put it up there. So now it will do this loop. As you can see, let's put this here, and there we go. So now you can see that it will press play. It will go and rotate into that specific rotation, so 180 degrees in total, and then go back into the first point, and then because of the flip-flop, then it'll go and do boom, the other way around again, and it'll be in a constant loop. And now, of course, I can detect it, it will flash, and it will activate the alarm. So that's it with this lecture. See ya in the next one. In this quick lecture, we will be replacing the current rotative sensor model with a new custom one, which looks awesome. So let's get started. Alright, so you will be able to download the custom models that we have built specifically for this course in the lecture notes. So what we're going to do is basically just get the whole folder that comes in with the FBX itself and also the textures, and just drag them into our content browser. As you can see, we'll have a few import options. Let's go ahead and just reset them to default, so all the options will be how we want. Make sure under the mesh, under advanced, that combine meshes is disabled, because this FBX will later split into 2 parts. So this is very important. Okay, so you say import all, and as you can see, it has built a new folder, and we have the new parts over here. So we have a material, we have the textures, and we have both of the models. So you can see we have a motion detector main, which is the part which will basically go ahead and be rotating and looking at. Don't worry about the textures, we'll apply in a second. And also the one that will be attached into the well, as you can see. So let's go ahead and use Ctrl-Shift-S to save everything. And what we're going to do is apply the textures into our material. So let's go ahead and open up our material. And I'm going to do is hold Ctrl and open spacebar, so we can go ahead and get this content browser on the material window. And now we can just go into the sensor model, just open textures, and we have a whole bunch of them. So in this case, what we want to do is get this motion detector base color and just drag it. And we're gonna get the RGB and plug it into the base color. And basically this will give the color of our main material. We are going to go ahead and get the next one, which is gonna be the emissive one. So just drag it. Again, the RGB, plug it into emissive color. This will basically bring the red spot to life, as you can see. We are then going to go ahead and get the normal one and just drag it, the RGB, into the normal input over here. So it will just give it some like bumps and 3D aspect. And then lastly, we're going to get the roughness metallic. Just drag it and drag it into roughness, okay? And this will just give it the shines of this metal properties and so on. So just apply this material, save it, and now yes, we can go ahead and close it. And now we open the models. As you can see, they will have this materials applied, and they look absolutely awesome. Now we're gonna be needing to do 2 quick more things. So let's get our motion detector main. So just drag it. As you can see, the pivot is not correctly placed. It's basically more down into the right, sorry, into the left. So what we're going to do is basically go into this section mode and go into the modeling tab. So we have a lot of options that we can touch over here, but don't worry, we're gonna go into a simple one, which is going to be the pivot, which is right over here. So in this pivot, what we can do is just go ahead and select center. As you can see now, the pivot will be in the center of the mesh. We can say accept, and as you can see, the pivot is right over there. And the model for the whole content browser just changed. We're gonna go ahead and select the other one, so the one that is in the mount, just drag it. We have the same problem, so in the modeling mode, just go and select the pivot, go ahead and select center, it's now in the center, press accept, and now the changes will be applied to the whole FBX in the content browser. Go ahead and save everything, go back into selection, and now we have everything correct. We can go ahead and delete them, and you can see when I drag them now it's applied. So let's go into our blueprints folder, open up our sensors and alarms, and open up our rotative sensor blueprint. On here, what we're going to do is go into the viewport, and we're going to start applying our models over here. So once again, let's hold Ctrl and open spacebar so we can get our sensor model. And let's go here. And the first thing I'm going to do is get our wall mount, just drag it. I'm going to go ahead and drag it into the default scene root. So it will be just applied there under the parent. So now we have it over here. What we're going to do is change the scale. So with the lock selected, let's put it at 2. So it is just a bit bigger. And then what we can do is go ahead and rotate this to be 90 degrees. So you can see now it will be correctly facing the backwards of the wall. And in this part, we will connect it with the other one. Actually, sorry. We need to connect this to 180 degrees. So now we can just put this back here. And it will be correctly facing, okay? So just like this. With that said, now we can go ahead and open this again, get the main one, and just drag it, and this time will be again under the default scene root. And let's go ahead and it basically put it as a child of the other one, drag it again into the default scene root, go ahead and change the scale to be at 2, reset the location, and then once again, I'm gonna go ahead and rotate this, but this time will be the other way around. So now, yes, it will be 90. Now let's put the 30 back to 0, and then we can just put it a bit forward. Now, let's go ahead and get this and put it inside of the head, because the head was the thing rotating. So now when it will rotate that main aspect. So let's go into the head and disable the visibility. And as you can see, we have the other motion detector there. So we're going to go ahead and join them a bit more. So we can change the snapping to be a bit less. Maybe like this. Maybe like 1 will be great. Yes, there we go. Put a bit down. And that will be great. So you can copy my same properties as you can see over there. And then with that said, that will give us the option to delete the front because we won't need it. And now we can compile. As you can see, you can have it over there. And we go ahead and press Alt S. You can see the motion detector going ahead and working. Now let's move a bit this spotlight that we built and the detective trigger, because now it's more in a incorrect place. So let's go ahead and just get the spotlight and just drag it a bit in front and up. And so it basically will kind of match a bit this point that we have in here. So kind of like this. It doesn't have to be exact, okay, but a bit like this. So you can again copy the same parameters that I have. So now, yes, we can now test this, and as you can see, it looks absolutely amazing. I love it how it looks. So now we actually have our rotate the sensor correctly set up with this really cool model. So go ahead and see ya in the next lecture. In this lecture, we will be setting up the other type of sensor, the bar sensor. So let's get started. Alright, so let's go into our blueprints folder, sensors and alarms folder, and we're gonna be making another child of our BP sensor. So just right click and go and create a child blueprint class. In this case, let's rename this to be BP underscore sensor underscore bar, and let's go ahead and open this blueprint up. So basically this will consist on a wall of different bars that are like cylinders horizontally placed. You'll see it better in a second. But first of all, let's go ahead and add the trigger, which when the player goes through, it will detect. So we're gonna go ahead and add a new component. This will be a box collision, and I'm gonna rename this to be a trigger. So now what we can do, instead of changing the scale over here, we're gonna be changing it on the box extent, because that's how you're meant to in this type of collision triggers. So we're gonna be putting in the first axis 150, in the second one 5, and in the last one 130. And this will just create this wall, which will act as our trigger when the player passes. Now let's go ahead and also just add 90 degrees in our rotation here, so it will be facing the correct way. Actually, it will be minus 90 degrees, okay? It doesn't really matter, it's the same thing, but I just like to have my things, you know, pointing at the forward of the actor, which is in this case to our right. Great, so with that said, we are now able to start adding our bars. In this case, our bars will simply just be cylinders, like I mentioned before. So we can just go, select the scene root, and just add a cylinder. In this case, we're gonna go ahead and name this bar space 1, and when we duplicate it, it will automatically just change it to 2, 3, 4, 5, etc. In this case, we're gonna be having 8. But first of all, let's set up the first one. So in this case, our scale will be, so let's unlock it. And for the X, it will be 0.1, so be very thin. For the Y, again, 0.1. But this time for the Z, this will be 3, because it will be more longer. And you can see it will kind of cover, as you can see, the trigger that we have already built. Now, what we have to do is I'll just rotate this around, you go 90 degrees with your rotated tool. Go ahead and make sure that you have snapping on around 10 degrees, whatever you prefer. And now what we can do is go and get the trigger and put it up. So it will begin right with our first bar. And basically it's because this is right now ground 0. So when you place the blueprint in our level, it will start at this point. So it's better to like build up instead of having it under the ground, you know what I mean? So what we can do now is just go and apply a material. In this case, we already have the rotative sensor material, which will work perfectly right now. And let's go ahead and find it, which is this M_detection zone. So in my case, right now, temporarily, we're going to be using the same one. So let's go here and use with the arrow, go ahead and apply. Great, so now what we can do is select our bar 1 and then press Ctrl D, and this will duplicate it. As you can see, we already changed the 1 with the 2, and it will be very convenient for us. So now what we can do is in the axis, just go ahead and put it on 27. So now we have some separation, and we are going to be doing this 8 times. So let's go ahead and duplicate this again, enter, and now here what we can do is add 27 into the current Z, so it'll be again with the same spacing. Duplicate this once again, bar 4, add 27, then again duplicate this, bar 5, add 27, again selected, duplicated, bar 6, add 27, and then 2 more times, 7, add 27, and then lastly 8, and add 27. Great, so that will be our bar sensor already set up. You can compile, save, and as you can see, when I go into my level, let's go ahead and place it, for example, here. I can just let's go into the BP sensor bar, drag it in, so you can see, there it is. Great, so right now I could, go ahead and press play, and of course, nothing will happen, but because we have our trigger box, and we have our colliders with our bar sensor, we're gonna go through. So the first thing we have to do is disable the bars, like the cylinders collision, because we only want to have the collision with our trigger. So let's select the whole bars, okay, so just with shift, go down in collision presets and put it in no collision. And now in the trigger, let's go ahead and make sure that in here we have in the collision presets overlap all dynamic, and now we can go ahead and go through our bars, but it will basically send an event to our blueprint, so we can now do things. So now, because we have already done it with the other sensor, your challenge is going to be to go ahead and make the component begin overlap and call the parent event that we created at the first lecture of this section, which is the detect player. So I'll leave that to you. We have implemented it a couple times before, so it's time to give it a shot on your own. Give it your best effort, pause the video, and when we resume, we'll go and find a solution together. Welcome back. Okay, so let's go ahead and select our trigger, and we're gonna go down until we see this on component begin overlap. We're gonna add into the event, and down here what we can do is just go the detect player event that we created before in our parent, and it's the exact same one that we are also using in our rotative sensor. They're exactly the same. And once again, we're gonna pass the other actor, which is the actor that has just gone through that trigger, into the actor detected. And with that, we can just compile, save, and just press play, and you can see now when I go through this sensor, it will go ahead and start the alarm, and it will also make that sound and also that snippet of light intensity that we did in the parent sensor when we started. So that's it for this lecture. See ya in the next one. In this lecture, we will be creating a lever so we can activate or deactivate the bar sensor. So let's get started. Alright, so let's go into the blueprints folder, sensors and alarms. Let's right click and create a new blueprint class, and this will be an actor. I'm gonna name it BP_lever, and let's go ahead and open this blueprint up. So let's begin by adding some components so we can get the shape of our lever. So the first thing we are going to be adding is going to be a single cube, and then this will be named base. Okay, so we're going to change the scale, make sure to unlock it, and we are going to be putting this at 0.05, and then in here will be 0.3, and then here will be 0.4. So it will get this type of size and shape. So it's like the base when where the lever will be like on. You know what I mean? So then what we're going to do is also in the default scene root is add a sphere collision, and this will be our trigger. So when the player gets into this point, he can interact with this specific lever. So let's go ahead and put a bit forward, and let's put the sphere radius to be around 60. So when our player will enter in this area, we can interact with the lever. Okay. Now let's go ahead and also let's make it outside of the base. Yeah, using this default scene root, and let's go ahead and add our lever, which will be a cylinder. So let's name this lever, and this will be the actual thing that will rotate everything. So let's put the scale to be correctly. So in the x-axis, let's put it to be 0.05. In the y-axis, it will be 0.05 once again, and then for our z-axis, it will be 0.5. Okay, great. So with that said, we're gonna put in the rotation for the y-axis, which you can see that it will be rotating the lever at 120. Okay, so it'll be in this position over here, and with that said, that will be great. So now as this will rotate, our lever will be rotating, which is exactly what we want. So there we go. So now inside of the lever, I am going to be adding another component, and this will be a sphere, and this will be like the handle where we're gonna go ahead and grab our lever. In this case, let's lock it, and let's put our scale to be maybe at 2, something like that. Let's go ahead and just put it in this point over here, just at the edge of our lever, and we can go ahead and change the material. Let's put it to be this green one, for example, just for now. Great, so now we have our lever set up. We can now just go and, for example, put it in our scene. So let's just go and get this, just add a new cube in the scene. So just quickly attribute prod, shapes, cube, and now I can just put this over here, and then I'm gonna rotate this to be facing this, and then I can just go ahead and drag my lever, and then just go ahead and rotate it, and just put it in place. Okay, as simple as that. Let's go ahead and change it from world transform into the local, so we can just have the axis where I want. And as you can see, we have the lever here. Of course, right now we cannot interact with it or anything, but now we will do in a second. Great, so let's go ahead and make the code that this lever will basically rotate up and down and be able to do things. So let's go back into our BP lever and make sure to save everything with Ctrl+Shift+S. Very important to be saving progress as we go, because things may crash and things may go very wrong. So always save. Alright, so let's go into the event graph. Let's delete all the unnecessary events. Let's right click and create a new custom event. And this will just be use switch lever. Great, so now on here, what we can do is create a new timeline. So you say add timeline, and this timeline will call pull lever. And basically, this will be in charge of changing the rotation of this lever. So from 120, it will, rotate to another type of degrees. So it will be like moving. So just double click on this timeline, and we have already used timeline for our parent sensors when we use the spotlight functionality to detect the player. So it's going to be the same thing. So the length will be 0.3 seconds. Okay, so we like very fast. And we're going to be adding a track, a float track, because we're going to be interpolating between one rotation into another one with an alpha. So this track will be called the rotation. So rename rotation, there we go. And then we're going to right click at any point and add a new keyframe. So the first one will be when the time is at 0 and value at 0. They're going to be right clicking any part of the screen, add another keyframe, and the time will be at the end. In this case, it will be 0.3 seconds. And then the value will be when it's 1. So when the alpha is at its highest concentration. Then we can just go ahead and click these two buttons, and it'll be aligned. You can see it's just in constant timeline over here, which is what we want. So we just go from this rotation into another one like so. Nothing crazy, is what we want. So now we can get this little output, which is this float, and you say lerp rotator. And this will basically transition between this rotation into this one by this alpha slowly with time. So let's go ahead and just get our lever, just drag it, and then say set relative rotation. So we're gonna be changing the rotation of this lever. Let's go ahead and plug it in the update, and now just plug the output of our rotator into the new rotation in our lever. Great, so with that we can start to apply the rotation that we want the starting point to be and the end point to be. In this case, right now our lever is starting at 120 degrees. And let's go ahead and end on something, let's say around 50. As you can see, now I'll be pointing downwards. It's like we grabbed it and switched it, and that's what we want. So let's go and put this back to 120, which is the starting point. And let's go and put the y-axis 120, and then the y-axis in the B, this will be 50. So basically it will go from this rotation into this one over a couple of times by the alpha of the timeline. Great, so we can preview this. So what we're going to do is just add the begin play, and we're going to do exactly what we did with the alarm. Just quickly just preview this to test. So what we can do is just call after maybe 2 seconds the switch lever. Okay, nothing crazy, like I saw. And now we can just go ahead and press play. You can see our lever, and in 2 seconds, there we go. You can see that it rotated downwards. So it is exactly what we want. It is working great. So now let's also just do a couple more things. First of all, let's play a sound. So we say play sound, and this will be at location, and let's find a cool sound. Now, in my case, I'm going to be using one from the started content that we imported, and I'm going to be choosing this floating UI close, okay, which is like you got the lever and pull it down, nothing crazy. Okay, let's get the location and say get actor location. So it starts at this point, and then what we can do is apply an attenuation. Now in this case, because we already have an attenuation that we can use, which is great for us, I'm going to be using the sensor one, not the alarm one. I'm going to be using the sensor. Okay, we are not going to be creating a whole new attenuation only for the lever. If we can reuse things, it's great. Okay, so let's go ahead and choose that attenuation, and now it will play that sound too. As you can see, if I press play, go here, it will play that sound. Great. So that's it with this lecture. In the next lecture, we will be creating an interface so our player can interact with the lever. So see ya in the next lecture. In this lecture, we will be creating an interface so we can interact with our lever. So let's get started. So let's delete the begin play thing, because now our player will do so. And let's go into our blueprints. And what we're going to do is create an interface. An interface will allow us to communicate with other blueprints in our game without directly needing to cast into them. So let's go ahead and do so, and you'll understand it much better. So just right click, add the content browser, and then go under the blueprint section and create a new blueprint interface. And this will be called BPI as a blueprint interface. And in this case, this will be a generic one for interaction. So I'm gonna say interact. Let's go ahead and open this up. As you can see, instantly it will create a new function. In this case, let's just call this interact. So now any actor in our world may have this interface and may have this function. So we basically can go ahead and call this function from whatever place we want at any time, and each actor will execute its own code. Now, it might not really make a lot of sense right now, but don't worry, when we start to actually apply it, you will understand it much better. We can also add inputs, outputs, and so on, but for now, we won't need, okay? So we can just leave it like this. So just compile, save, and just close it. And now in our lever, we're gonna go into the class settings and add this interface. So we can go and add an interface under this implemented interface section, add BPI_interact. And as you can see, now we have a new section. If we expand it, we can see this interact. So what we can do is double click, and this will create a new event, as you can see. So now let's put this up. When the player in this case will interact, and we'll call this event interact of this blueprint, now we can just go ahead and call the switch lever. And now our player will be able to interact. So now let's go into our player blueprint and apply that interaction. Let's open our BP wrapper. So just double click on it. And now what we need to do is also just create a new input to interact. So let's quickly do that. Just go into our input, just right click, input, action, IA. interact. We don't have to open it, we can just go directly into the context and just add a new mapping. And in this case, this will be the IA interact. And now we can just go ahead and select this button, press the E key in our keyboard, and it'll be assigned. Great, so now we can close it. Back in our player blueprint, we can just right click and call the IA interact. And then the action events. And now when we press this button, what we're going to do is do a for each loop. So basically, we're going to be looping through an array of objects. You're going to be wondering why. Well, basically, we are going to be getting all of our overlapping actors. And why are we doing this? Well, basically, as you can see with our lever blueprint, we created this radius. So if we are inside of this area, our player blueprint will detect this as an overlapping actor. So basically, as a conclusion, we can go ahead and access that lever that we're basically overlapping on. So in this case, what we can do is ask it, does it implement an interface? In this case, we're going to be asking if it basically has that interact interface that we have just created. Let's go ahead and make a branch, so it will only continue if this is true. And if so, we can interact it. And because this is universal, we don't need to cast to the BP underscore lever and then go ahead and just get the pull lever event and so on. We can directly just go ahead and say interact. And now, yeah, we just go ahead and whatever object we're trying to interact with, and it will contain that interface, it will interact with it, which is very, very good. And it's exactly what we want to be modular, universal, and quick and easy to use. So now basically our player will be able to detect whatever actors are overlapping. In this case, it will be our lever because we're inside that radius. And then if it contains that interface, it will go ahead and use it. So now here, because the code that runs that interface will basically switch the lever, it will switch the lever. So now we can just go ahead and press play. You can see I can go here, press E, and I can turn it upside down, as you can see. Now, of course, I'm gonna do it more times because we don't have any reverse options. But as this lecture is coming in a bit long, I'm going to be ending this one, and then we'll continue in the next one. So see ya in the next lecture. In this lecture, we'll finish up the lever. So let's get started. Alright, before going ahead and making that we can pull up the lever, we are going to be adding a new variable that will basically be referenced to a specific bar sensor in our world, and we can turn it on or off. So let's go to our lever, and also we can close already the player blueprint. We won't need it anymore. And we can add a new variable. And in this case, this will be the output actor. So this will be universal, so we can interact with whatever actor we want in the world. In this case, we're going to be using for the bar sensor, but it doesn't really require it to be only the bar sensor. It can be whatever we want. So let's change this to be just a BP, an actor. It's actor, you can see object types, actor, object reference. And what we can do is go ahead and click this eye icon, so it is public. So now in the world, I can just select my lever, and now you can see this variable on here. So now what I can do is just click this pipette, and just now select my, where is it? Let's see if I detect it. There we go. There we go. BP sensor bar. You will need to go and get the outline of the trigger. So now I can go ahead and select it, and that will be the variable and the actor that will basically enable or disable. So now I can just go get this over here and make sure to only continue. First of all, let's get it. Right click, convert to validate, get it. So it will only continue at this value. So if there's an actor filled in this variable, because if not, it will give us an error. So here's the challenge. You need to call the interface function interact to the output actor. It will be very similar to what we did with the player interaction system. So a bit of a hint here, you can use the does implement interface node and call the event interact to the output actor. We have already done it before, so it should be very simple. So just give it a go and pause the video, and we'll cover this in a second. Welcome back. So what we're going to do is just make sure that it does implement an interface. Once again, it will be our BPI interact. So we're going to be doing a very similar thing to what we did with the player, but in this case from our lever. If so, if it has that interface, we can interact with it. So we're going to be going ahead and just going and interact. I'm going to go and get the BPI interact, and there we go. So now it will be basically activating or deactivating that specific actor. In this case, that bar sensor. And now that will be on play. So now we can go ahead and test this. But of course, we have to add that interface into our bar sensor. So let's go quickly into our bar sensor. So there we go, bar sensor. And now let's go into class settings once again to add this BPI underscore interact. So now we can double click to add this event. And in this case, when we call this, it will basically, we're going to create a new variable which is activated. In this case, let's compile and let's mark it as true as default, because as default, when the game starts, our bar sensor will always be activated. So basically, let's drag this over here and let's make it. If it's not Boolean, so if it's not activated, we are going to be activated. So in this case, what we can do is just set actor collision to be true. But if it's false, that means that it is basically active, so we will need to disable it so it will not detect our player. Great. So with that said, I can just compile and we can give it a go. So now when I press play, if I go directly into my bar sensor, it will detect the alarm. But if I go and just get the lever and I'll pass to the bar sensor, as you can see, now it will not give that output into the alarm and it's basically deactivated. So that's great. That's already working, right? So let's go quickly bar sensor and also use disable of the bars. So we will not be able to see them. So we have that feedback that is actually, disabled. So let's just go ahead and get all of this, extract them. And there's a whole bunch of them. And in this case, let's go up here. And we're gonna just go ahead and just set visibility. And let's plug this here. And let's basically plug them all into our target. So we'll go ahead and enable them or disable them all at once. Great. And then what we can do is just go ahead and, in this case, this will enable it. Let's copy, paste. In this case, it will go ahead and disable them, okay? So let's also select them, move it down so we have space to put it here, and there we go. So now basically, as you can see, when we enable this, it will go ahead and disable them. I can now go through, and then of course, it should do the opposite, but we need to also do some code so we can call it again. So let's go into our BP, also, we need to go here, and in activate it, we have to just set it to be here. In this case, it will be true. And in this case, it will be disabled. Because if now we cannot call it again, now we can. Enable and disable, as you can see. Now let's go ahead and make that the lever can return back up. So what we can do is also create a new variable and it will be activated. And in this case, this will be a Boolean. And by default, will be disabled this time. So now I can just go and do some more space here and make a branch. So if our lever is not Boolean, so it is not activated, I will go ahead and play our current timeline, which will pull the lever downwards. But if it is already activated, we want to do the inverse. So in this case, we can just plug it into reverse. And with that, you will see I can go and press it, it will go down and disable that, and then do the opposite, and the lever did not go down because I missed something. We have to also go and just get the activated to be set. So you just drag it over here. In this case, it will be true. Let's copy, paste, drag the false, and this will be plug it here back, and then disabled. So now I can go ahead and deactivate the bar sensor and enable back again. You can see that the lever will go back and forth. So everything will be going ahead and working exactly like we wanted. So that's it for this lecture. See ya in the next one. In this section, we will create the crouch locomotion state with a new animation blend space and a name state. We will make a dummy that we can practice with. we will import our takedown animations and set up motion warping. And finally, we will make that we can still take down the dummy. So let's get started. In this lecture, we will create the crouched locomotion blend space, so let's get started. Alright, so let's go into the characters folder, rubber, and now let's right click and create a new folder. And let's call this crouched. Now let's go ahead and enter in this folder, and what we have to do is import the two animations, which will be crouch idle and crouch walk. So let's go ahead and download them. Now I'll be leaving them in the lecture notes, so you can just go ahead and grab them. And the other thing I'll have to do is select the two, drag them into the content browser, and then select the skeleton. Just in case, let's go ahead and click the reset to default button, just in case there's something to move. But what we have to do is select the SK mannequin skeleton, okay? Not the alt SK mannequin skeleton, it will be only the one that says SK mannequin, which is the UE5. With that said, everything should be fine. So we're going to say import all, and now the animations should start to import. As you can see, we have them here. So if I open crouch idle and just put it here, you can see the crouch idle animation working perfectly, and also we can see the crouch walk working perfectly. There we go. So now what we need to do is create the blend space, okay, which we already have done in the past. As you can see, for our walk jog, in this case will be exactly the same, but for our two crouch animations. So let's go into our folder, right click, animation, go into legacy and create a blend space 1D in one direction once again. Again, let's select the SK mannequin, and now let's go ahead and just name this crouched blend space 1D, and let's open this up. Alright, so what we have to do is go into the axis settings in the horizontal axis, and let's change the name to be speed, just as we did with the other one. Now in this case, the maximum speed will be a bit less, because when you're crouching, you go a bit slower. So for now, let's put it something as 350, okay? But we can play with those. Now let's go ahead and turn on snap to grid, as I like to, snap it into a perfect position. And we can put some smoothing time of maybe 0.2, so it'll be a bit smoother. Alright, so now in timeline, we can go into the asset browser, which if you don't see it, you can just go ahead and search it in the window section. And now let's go ahead and search crouch. And now we can get our crouch idle, just drag it into the left part of our timeline, and then crouch walk into the right. So now if I hold Control and move the mouse around the timeline, you can see how as the speed increases, my character animation will change also. So that's great. Everything will just work. We can now go ahead and save, and we have it ready to use it in the next lecture. So in the next lecture, we'll be creating these states in an animation blueprint, so we can go ahead and introduce the new blend space that we have created. So see ya in the next lecture. In this lecture, we will be creating our crouch locomotion state in our animation blueprint. So let's get started. Alright, so let's enter in our characters folder, rubber, and as you can see, we have our ABP rubber. So let's go ahead and open this up. Let's go into our main and end graph. So you can just click, for example, in here. And then you can see that we have our state machine for locomotion. The thing is that we will need to create a new state. And for that, we have to create a new state machine. So let's go into our name graph. Just right click and type state machine. As you can see, we have it here. So let's click it. And now this will be our main states. So basically, this other state machine will control all the different states. So normal locomotion, crouch locomotion, and whatever else we'll have in the future. So let's go back one time. And what we need to do is save this whole locomotion state in a sort of cache. So we can now go ahead and use it. As you can see, you need to be very organized with the tabs here. They can fill up very fast. So we need to save this in a type of cache so we can use it in our main state. So you will see better what I mean with this. But what we need to do is hold Alt to close the pin. And in locomotion, use extend this a type cache. New save cache pose. Now this, just go ahead and click this and go into the name and just type here locomotion. And this will be our main locomotion. So now we can just go ahead and move this state upwards and now plug in our main states into our output pose. So now inside our main states, which is double click, we can now go ahead and create a new state. This will be our normal locomotion. So let's just name this locomotion. And here now we can double click and put in our cached locomotion. As you can see, use cached post locomotion. So now we are using that specific locomotion state that we created from outside. So it's way more cleaner. Just imagine the cache as a pen drive. We are saving this information in a pen drive, and then here we're basically using it. Great, so now what we can do is go and create a new state for crouched in our main states graph. So let's just right click, add state, and this will be crouched. So now what we can do is hover in the border of one of the states and just drag it into the other border. And you can see this will create a transition as we have done before. So now we can do the same but backwards. And what we have to do now is basically create some parameters for the transition to happen. So in this case, let's go down to variables and create a new variable. And this will be is crouched. And of course, it will be a boolean because it will be true or false. So now let's double click on the transition from locomotion to crouched. And now let's just drag our is crouched, which will mean if this is true, it will transition there. Let's go back. And now we can go from crouched to locomotion. Double click here. And this will be the same, so let's get it crouched, but it will be the opposite. So it will be not true, so no boolean. And now we can just go ahead and drag that there. So now we have the transition set up, but of course, crouched is empty. So let's open this up, and we have to find our locomotion that we created, which is the blank space. So let's just get our crouched blank space 1D, drag it here, and there we go. Of course, we have to plug in the speed, but we already have a variable set up for that, which we created in one of the last lectures. So let's go ahead and just drag this, and now the crouch blank space will be correctly set up. As you can see, we already can test this if I select is crouched, go down, and enable is crouched. As you can see, I go into the crouched position. And on top of that, if I were to go in speed and go and put this to 350 and then compile, nothing will happen. And this is because basically the Venn graph is in the update setting it where the get pattern is. But if I disable this and go back here, and the speed is 350, disable this 350, you can see that now it is walking. Okay, so the thing is that this variable is being overridden, that's why it didn't affect the speed value here, but don't worry about that. As you can see, if I put a value here, it will be walking. Let's go back, put the 0, connect this, go to Venn graph, connect this, go into speed, and put this back to 0. Okay, there we go. So now this will work if we are in the crouched blank space. So let's go into our is crouched, and let's disable this because by default we will not be crouched. But of course I could try this to just put is crouched by default and press play. As you can see, I will be playing, and you can see that the animation does not exactly match my speed. This because my character speed right now is not 350. Okay, but don't worry, in the next episode where we create all the crouching logic, we will set up the speed to be correct and also the capsule collider and so on, so we can go ahead and press a key, crouch, press another key, and crouch. So that's it with this lecture. See ya in the next one. In this lecture, we will be coding all of the crouching logic. So when we press a key, we'll crouch, press it again, and crouch, and also pull up the camera a bit. So let's get started. Alright, so the first thing we're going to do is create a new input key. So let's go into our input folder, and just right click, go into input, create a new input action. This will be IA underscore, and then this will be just crouch. We don't have to do anything. Okay, by default, it will work perfectly with our settings, as the little boom and stuff. So we just have to go into the context and just add it over here. So let's go ahead and just add a new action mapping as we did with the other ones. And now this will be our IA crouch. Of course, here we have to assign a key, so we can search it. You just press this button and then press a key on a keyboard. In this case, I am going to do Control, but of course you can choose whatever key you want. And that's it. We just need to save it, close it. Now let's go into our blueprint, our character blueprint. So let's go into blueprints, BP rubber, open it up. Now let's go and find a space. In this case, it will be good down here. Right click, IA underscore crouch. There we go. So we're gonna go into started and let's make a branch. So if we are not crouched, we're gonna go ahead and crouch our character, and if we are already crouched, we're gonna go ahead and uncrouch it. So we will need to create a new variable. So let's go down to variables, add a new variable, and those will just be crouched. So let's just get it and then do a not boolean. So if we are not crouched, we will go ahead and set crouched to be true. Copy paste this, and this will be the opposite. Set it to be false. Great. Now, from our animation blueprint, we can grab this variable and put it into our other variable that we have there. So the transition will happen. So let's go ahead and do this. Go into our content, characters, rubber, ABP rubber. Let's open this up. As you know, we created in the last lecture, this is crouched variable. So we can basically set it on or off depending on this variable here in our character blueprint. So let's go into our event graph, and basically you have all this stuff here. So in our player BP, let's go ahead and drag this, get it, right click, and do validated get it. So this will only continue if it's valid. So we will not have any errors. This is just some prevention, you know. Okay, so in here what we can do is get our variable, which was crouched, okay? Don't confuse this with the default one that is created by Unreal, which is from our character. No, we have to go into the default section and get crouched, okay? How we named it. And now what we can just get is crouched from here, set it to be whatever is there. So this is false, this will be false. If this is true, this will be true. So now as you can see, I'm gonna go into is crouched and by default disable it, which got a miss from the last lecture. Now when I press play and press Ctrl, I can crouch or uncrouch. Great, so now let's go ahead and change the character speed, because right now he can go very fast when he's crouched. So let's go into our BP rubber, and when we are crouched, let's go into character move component, drag it. Now we have this variable which we can change, which is the set walk speed. Set max walk speed. So in here, let's connect this, and this in this case will be 350. But when this is, you know, done, and we want to uncrouch, let's copy paste this, and we'll set it back to our value, which right now is 500 or 600. Let's see. So we can go in here, walking max walk speed 600. So let's go back and put this to be 600. So now, again, I need to connect this back again. There we go. Because it's accessing the component from the character movement. And now, when I crouch, I go slower, and I crouch, go faster. But as you can see, still our animation does not really match our speed. So what we can do is accelerate a bit our animation. Also, use Ctrl-Shift-S to save everything, just, you know, just in case the engine crashes or whatsoever. It's very good to use, you know, save every so often. Alright, so let's go into crouch folder and open up our crouch walk animation. Just double click. Okay, so on here what we can do is change the rate scale. That's basically the animation speed. So maybe 2 will work. So this is more of a try and error, so let's see what this looks like. Okay, that looks pretty good for now. I do like it, so let's go ahead and keep this. As you can see, when I uncrouch, I go a bit faster, and then crouch again, I go a bit slower. So that's great. Okay, so now let's go back into our BP rubber blueprint. And basically, let's code that our camera will zoom out slightly when we are crouched. So we have a bit more of vision. But of course, we'll do this with a nice lerp transition, so it will just occur nicely. And it will just not be like a straight up, zoom out, very cut off. So what we need to do is change the spring arm length. If I were to put this as, maybe 700, this will be more zoomed out and it will give us that effect. So basically this is the variable that we have to change in the spring arm. Right now it's set to 600, so cool. Let's go to the event graph and basically let's just get our spring arm, just drag it, and now you set the arm length, which is that variable. So when we crouch, and of course, as you know, when we are crouched, it's always this upper sequence, and when we uncrouch, it's the down sequence, we need to set up the arm length to be a bit higher. In this case, it's 600, so let's put it to be maybe 750. Okay, so now if I were to press play and I crouch, as you can see, the camera zooms out, but it is straight up like a pop-out. It doesn't look very nice, so we can do a nice transition. So here comes the challenge. You need to create a timeline so we can create a nice transition instead. So we have done it in the past for our rotative sensor. So if you remember correctly, we will need to add a float track, and then you can set the duration of this transition. In this case, you could put something that you feel that will transition correctly and look nice, like 0.3. And then you can place the two keys. So one at 0 at the beginning, and then the other one at 1. So at the end of the transition. So go ahead, give it a go, pause the video, and we'll review it in a second. So what we need to do is create a timeline, which we already have created for our sensor and so on. So what we need to do is drag this, add timeline, click enter, and let's call this crouch zoom out. Okay, so in this case, we're gonna plug this into play, and the other one, let's go ahead and just plug it into reverse. So it will just do the reverse as we are uncrouching, so we want to zoom back in. So it just makes sense to put it in reverse. So now here, let's double click in our timeline and create a new float track. In this case, this will be just the arm length, as that's what is changing. And of course, there we go. I don't know how to type. The length, the duration of the animation, of the transition, we could call it. Let's put something as 0.3, because it has to be kind of quick, but not so quick. So maybe 0.3 will work great for us. Alright, so what we're going to do is right click, add a new key, and this first one will be when the time is 0 and value is 0. Now just right click at any point, add another key. This time our time will be 0.3, so when the transition finishes, and the value 1. So it'll be full on in the other distance. With that said, we can go into the event graph, get our arm length track output, and just do a lerp, and this will be for a float. So we need to hold control and move it into alpha, so it will transition from one value into the other one. In this case, it will transition from being at 600 to 750. And now this output, we can plug it in here, and it will just go ahead and transition correctly. So we can go ahead and test that out. If I press play, let's put it in full screen so we can appreciate this. I crouch, you can see it zooms out pretty nicely, and then uncrouch and zooms back in. It looks pretty cool. Maybe it is a bit too quick, so we can go ahead and modify that. If we just go here, open up this, and put the length to be maybe instead of 0.3, maybe 0.45. Now remember that we need to go into the last point and put it to be the time 0.45, because if not, it would be exactly the same thing as the other point is in the middle. Okay, so with that said, we can just compile and test that out. Now, as you can see, the transition will be a bit smoother. And of course, you can create curves and whatever. Right now, we just have a linear interpolation, but I think this will be great for us. So I'm gonna go ahead and leave it like this. Great, so that's it for this lecture. In the next lecture, we'll go ahead and modify the player's capsule so it will shrink so we can fit in through smaller, kind of parts and sections. So I'll see you in the next lecture. In this lecture, we will make that our player's capsule collider will shrink when we crouch with a nice interpolation so we can fit in smaller areas. So let's get started. Alright, so let's go into the blueprints folder and open up our BP wrapper. So as you can see, this is what we did in the last lectures. So if we are not crouched, we will turn on the crouch to be true, we will reduce the player's speed, and zoom out the camera. So what we need to do in here is create a sequence. So this is a very useful node that will allow us to play different things pretty much at the same time. So first of all, it will basically execute this and then this. So here is where we can go ahead and execute this capsule reduction logic. So what we need to do is create a new timeline. So basically just call a timeline, and this will just be capsule height. Great. So let's just reroute this a bit so it looks a bit nicer. So let's just select one of the pins here, which is the then one. Double click. This will create a reroute pin, and we can just go ahead and move it up. So this will just make it look much nicer, as you can see. Let's also copy, paste this over here, plug this sequence here. The first execution point will be back into the reverse, but the other one will just go into the reverse of the capsule height. So basically, this is just a way of executing different code from basically one node. So we got into here, we'll first of all do this and then do this also, okay? So in here, we'll go ahead and just double click and create once again a new float track. And this will just be the capsule height. Change the length to be 0.5, so it'll be quite, fast, but with a nice interpolation. And let's just right click, create a new pin when the time will be 0 and value will be 0, and then another pin when the time will be 0.5, which is when the transition will finish, and value 1, which is when everything is fine and the transition has happened. Cool. So let's go back into the event graph, and what we can do is drag this and make a lerp, a float lerp. Once again, let's hold Control, move this into the alpha, which is what is changing. So it will go from this value into this one. In this case, we want to change our capsule collider. So if we go here, capsule component, this is what we want to change, the half height. Right now it is at 88, so we're gonna change from 88 to another value, okay? So let's go here, put 88, and the added value is gonna be around 50. We'll play with that in a second and see if it's correct for us. Great, so now here, let's get our capsule component, just drag it, and set the capsule half height. And this will be the variable that we want to change, and this will be, of course, our output. Great, so you can go ahead and test this. So if we select our capsule component and search for hidden in game, we can disable this, so now we can see it when we play the game. So you can see we have our capsule here, so when I go ahead and crouch, you can see that it gets smaller and then gets bigger. But we have a problem, and it's that our character will also lower down, and this is because we are changing our capsule height, which will affect our mesh because it is a child. So what we need to do is basically offset slightly the player's mesh, again with the same time, so it will look nicer, and basically smooth it slightly up. So let's go ahead and do so. And once again, we will just use this timeline. Now we can just go ahead and get the mesh and basically use set the relative transform. Sorry, the location. Relative location, there we go. So basically, we'll use set the local location of this mesh in this blueprint. In this case, what we want to do is right click and split this. So we only want to affect the Z axis, which is the one moving up and down. As you can see, this is the Z axis. So in here, what we need to do is create a new lerp. Drag this lerp, once again, a float. Move with Control to the alpha, and it will go from this value, which is -89, to -59. Because if I put this to be in -59, it will basically move slightly up, which is the perfect position for our crouching, okay? Let's just put this into Z, and with that said, we can go ahead and press play, crouch. You can see our capsule will shrink, but our player will remain there, and also it will work perfectly when we uncrouch. So that's it. As you can see, if I were to now just, for example, get this duplicated with Ctrl D, move it slightly, then with the scale tool, just in the Z axis, make it thinner. So let's do like this and move it up. I guess that in here will work great. You can see I cannot go. The capsule collider will collide. Oh my god, the alarm, the sensor got me. Let's go here. But if I crouch, you can see the capsule collider will, be smaller, and now I can pass. And I can go out and crouch once again. But there's a small problem, and it's that if we go here, as you can see, when I try to uncrouch, I can't, and it just bugs out, and I'm stuck. So this is what we're going to be doing in the next lecture. So basically use a small line trace to detect that we have an obstacle to be able to, not uncrouch. So you have to exit that area first. So that's it for this lecture. See ya in the next one. In this lecture, we will create an obstacle detection so that when we uncrouch, we won't get stuck on anything. So let's get started. Alright, so let's go back into our BP rubber blueprint. Let's open this up, and as you can see, here's where we have all the logic to crouch and crouch, etc. So basically what we have to do is before we uncrouch, we will need to create a small line trace up, so an invisible line that will basically touch an obstacle, and if there's an obstacle, we won't let our player continue and uncrouch. But if there's nothing, it will just continue up, and we will let our, the sequence run our player uncrouch. So what we need to do is create a function to have it more organized. So let's go here, function, create new function. This will be uncrouch obstacle detection. Alright, so basically on here, what we're going to be doing is do a fear trace by channel. Okay, so there are two ways that we can do this. We can just do a simple line trace or a sphere trace by channel. The thing is that the line trace might be too thin, and a sphere trace channel will just allow us that if we are slightly in the border but a bit off, still not be able to uncrouch because maybe our shoulder will pass or whatever. So basically we'll just prevent some little things from happening, and we just look a bit nicer, okay? Because it will just cover a bigger area because it's not a little thin line, it's more of a sphere, Okay, so the starting point will be our get actor location, so right now where our player is, and our ending point will be our get actor rotation, and from that what we need to do is get the up vector. Okay, so basically where the character is pointing upwards, and then what we need to do is multiply this by a value. So basically we'll create a point upwards in our player. So up vector will times it by something upwards through a distance. So we just need to go into this second pin, just right click and convert this to a float, single precision. So this will be the distance that this trace will go upwards. In this case, I found that 115 will work great for us. Good, so now we just need to add these vectors. So we just need to get this, add it, pass over here, and that will be our end point. Great, so let's put a little radius, maybe at least 15. We can play with that. But basically what I like to do is go into the draw debug type and just put this for duration. So we can preview and you see this fear trace by channel to see if the size, length, and whatever is correct. Great, so now what we need to do is create an output. So we can just select this output, add an output, and this will be hit. So if I hit something, let's just go ahead and pass this over here, compile save, go into the event graph, and now basically on here what we need to do is get this, move a bit more into the left, and basically drag our uncrouch obstacle detection here on the false. So when we uncrouch, and we will only continue if hit is not boolean. So if it's not true, we can go ahead and continue. Let's make a bit more space here, put our branch here, and there we go. So we have not detected anything. We can go ahead and continue. Let's go ahead and just add, double click this to add a reroute node so it looks a bit nicer. There we go. There we go. Cool. Great. So we can now go ahead and test this. I can now press play, and when I crouch and uncrouch, you can see this sphere, this red sphere happening there. So if I were to uncrouch here, the sphere is red, it isn't detecting anything, so I can uncrouch. But if I go here and try to uncrouch here, you can see that it detects something. Now the sphere turns green, so it doesn't let me to basically go ahead and uncrouch. But if I go out, I can. So you can see it's working perfectly. So that's it with this lecture. See ya in the next one. In this lecture, we'll import our takedown animations and set them up. So let's get started. Alright, so first of all, let's go ahead and create a new folder for them. So let's go into characters, rubber, and just right click, and let's create a new folder over here. Let's just call this takedowns. Let's go ahead and enter into this folder. So now we have to import the animations. In the notes or resources tab for this lecture, you have two animations available for download. So just download them, with that, we have the takedown attacker and takedown victim. So we'll have two animations. So let's go ahead and just select both of them and just drag them into our content browser. Great, so now let's select a skeleton. In this case, it will be the SK mannequin for Unreal Engine 5, not SK mannequin skeleton. Okay, so use SK mannequin, select this, and now with that said, you just go ahead and press reset to default just to make sure everything is set up like we want. Now you say import all. Now with that said, so wait a few seconds, and there we go. We have both of the animations. If I open this up, we have the animation for the victim, and we also have the animation for the attacker, as you can see. Great. So now let's go ahead and use Ctrl-Shift-S to save everything. So what we need to do now is create two animation montages so we can go ahead and call them from our blueprints later on. So let's select our takedown attacker, let's right click, go into create, and create an animation montage. In this case, we can go ahead and just, leave it like this, takedown attacker underscore montage. That name will work for us. Let's also do it for our victims. Just right click, create anim montage. And as you can see, this is pretty much exactly just our normal animation clip, but the anim montage, we can call it with specific notes from our blueprints. That will be very handy. And we can go ahead and add some modifiers, which we'll do so in some seconds. And the one that we want is the motion warping plugin. The motion warping will allow us to adjust a character's root motion to align to targets, creating a nice interpolation. So basically, it will allow our player to move with the animation's root motion of our attacker animation into the enemy. So for example, even though our player is a bit off and our victim, in this case our dummy, will be right here, it will automatically move to just into that location very smoothly, okay, with the animation's root. Okay, so let's go ahead and enable the plugin. Let's go up into edit, go into plugins, and now what we need to do is go ahead and search for motion warping. Is this one over here? It is in beta, but I have experimented with it and it works as we want. So let's go ahead and just click enable, and now we say yes. And now you can see that we have a pop-up to restart our engine, so it will, install the plugin. So let's go ahead and do so. Alright, so the plugin should be installed. Now if we search once again motion warping, as you can see now it's ticked. So now we can go ahead and close this window, and I'll go back into our project. Now what we need to do is open up our animation montages. In this case, we will only add the motion warping into one specific anim montage, which will be the one of the attacker, because the attacker will be the one moving into our dummy. So let's go ahead and open up our anim montage, and now what we need to do is basically go into the notify rag, just right click and add a notify state. In this case, it will be motion warping. Great, so now we'll have this, little node over here, let's say. So first of all, the motion warping will last, well, the segment of this block over here. So in this case, we want this to start at around when a character is starting to go ahead and move. So I guess that 4 will be good. So let's put it into 4, which is where our, player is starting to move. And then it will end where our player finishes to move, which will be, I guess, around maybe, 16. Great, so with that said, we have to adjust some parameters of motion warping. So let's go ahead and select it, and now in the details panel, we can expand the root motion modifier. In this case, we want to leave it as the skew warp, and now we just need to put a name. In this case, it will be just takedown, and now we can leave everything as default, and now just, put warp translation to be true because we want that to be true. Ignore z axis because we don't want to move our player up or down. The mode will just be linear, that will work for us. Warp rotation, we want to leave this true because if our player is looking slightly to the left, our dummy to the right, well, we want to, properly adjust the rotation too. So really, all of the default parameters will work great for us, but I'm gonna change the warp rotation time multiply, which is how, the speed that it will basically rotate. So let's go ahead and just put this to be 0.2. It will just be a bit smoother and it will just look a bit nicer. Great, so with that said, we have all the animations set up for the next lecture. So that's it for this lecture. See you in the next one. In this lecture, we'll set up the takedown interface, so our player will take the action and receive all the parameters that it needs. So let's get started. Alright, so let's go into the blueprints folder, right click, go into the blueprint section and create a new blueprint interface. We have already done it in the past, you can see with the BPI interact, so it'll be more easy for us. Let's go ahead and just name this BPI underscore, and this will just be, in this case, we're gonna also prepare it for the future for our AI guard. So let's just put guard, and that will basically, allow us to use it in the future, not only for dummy. In this case, of course, we're gonna use it for dummy, but it's for testing. So let's go ahead and double click to open up our interface. In this case, let's rename this function to be just takedown. Okay, so this will require some outputs that our player will want to receive. In this case, the first one will be, as you can see over here, the ref pose. Basically, what we need to create is a specific position in our dummy blueprint. So in this case, it will be another character, which will be a bit more here, where the player will need to go ahead and move with motion warping. Okay, this will of course be a vector, so it will be with different axes that it has to move. Then we'll go ahead and add the rotator, which will be the rotator, and let's name this rotation, which is the rotation that the player has to move. Let's now add this, which will be can takedown, because maybe some specific enemies, we don't want them to be able to be take down. So let's go ahead and just put this to be boolean. And now, last but not least, let's go ahead and just prepare this for the future, which is gonna be AI actor. Okay, but for now, we'll go ahead and just leave this empty. Actually, you know what, let's go ahead and remove it. We don't need it for now. Let's not add it more stuff which we will not need right now. So let's go ahead and just compile, save. That is everything that we need for our interface. So let's go into our dummy and let's add it. So let's go into class settings and go into the implemented interface, and then go ahead and just add our guard. Here, there we go. And you can see that we have a new interface created, which is the takedown. If we double click on this, it will create it. As you can see in here, we will go ahead and play all of the victim animations and things that we need from our dummy perspective, and then we'll pass all of the information that the player will receive, which is this 3 points right now. Okay, let's go ahead and just quickly create the ref pose. So let's go ahead and just select the capsule component and use skeleton mesh, and this will be our reference. Okay, in this case, let's put the skeleton mesh once again to be skin mani simple, which is our player, and let's put this back to be -89 and -90, so it'll be in the perfect position. Now let's go ahead and just change the animation mode to be an animation asset, and now what we can do is search for the attacker animation. And now we can disable looping or playing, and let's put our initial position to be, let's say, 0.5, which is halfway of the animation. Now as you can see, we have this part over here. So what we have to do is place our character where we want our player to be when you take down in the gameplay. So for making things easier, we can select our mesh, which is our dummy itself, and also just temporarily put this to be an animation asset, but this time it will be the victim. Now we can do the same, put this into 0.5 without looping or playing, and now we have our perfect position. So now we can just go ahead and put our player reference where we want, as you can see. So a good location that I have found is in the x-axis is -56. Then for our location, it will be just 1 over 2 slightly to the right, and then the Z will stay the same. As you can see, right now our player is a bit more forward than our mesh itself, and this due to basically remotion. So let's go ahead and enable remotion, which is very necessary not only for moving the animation, but also for motion warping, which is what I explained in the last lecture. So let's go ahead and go back into our takedowns animations, and let's go into our takedown attacker, and then go ahead and go down and enable root motion. This will allow the animation to move and move our own character, and then allow motion warping to work. And now let's also do the same with the victim. Go ahead and just enable root motion. And that's it. Now go back to dummy. As you can see, it is in the perfect position because the dummy itself moved a bit back because of the animation. So now that is perfect. We can select back our normal mesh and just put it to be a normal animation blueprint, and just select our reference. Make sure down over here that the collision preset is set up to no collision, so it will not affect our gameplay. And then on top of that, let's go and search for hidden in-game and enable this. So when we play our game, we will not see our reference. It is only for us for editing the game. Great. So with that said, we will have our dummy set up. So in the next lectures, we can add all of the logic that it needs to be able to be taken down. So that's it for this lecture. See you in the next one. In this lecture, we'll set up the logic for the takedown of our dummy, so let's get started. Alright, so let's open up our dummy blueprint. So we can just select the one that we have in our level and just press Ctrl E. This will just go ahead and say Ctrl Edit and open the blueprint up. Nice shortcut. Okay, so what we need to do on here is basically apply all the logic into our takedown interface that we created earlier. So in this case, what we want to do in here is basically, first of all, only continue if this specific guard or dummy in this case right now will be able to be taken down. So let's go ahead and just create a new variable, and this will be can take down. So we'll only continue if that's the case. By default, I'm gonna go ahead and just say compile, select can take down, and put it to true, because by default I want all my enemies to be able to, be taken down. Great, so if that's true, we can go ahead and continue, and in this case we want to play an anime montage. Okay, so it will play an animation montage which we created earlier. In this case, we want to play our victim montage because we are in the dummy, right? So let's go ahead and select this, and now we'll play that montage. And then what we want to do is, after some time, we want our victim to ragdoll into the floor because it died, right? Our takedown happened, and after some seconds of the animation, we want our dummy to just fall. So what we need to do is create a custom event, because in here we cannot apply any delays because it's a function, and function does not allow interruptions in its timing. So let's go ahead and go into the event graph, go down over here, right click, and create a new custom event. In this case, this will be the takedown ragdoll. Okay, so in here, indeed, we are going to be playing our delay, which will put a time in a second, and then what we want to do is ragdoll our mesh. In this case, the easiest way to do so will be just to take our mesh and then you set simulate physics, basically enable the physics on the specific component, which is our mesh. And then we just go ahead and just, kind of ragdoll with all of these bones. Now, one thing that we have to make sure for its collision to work is go down, and then in the collision presets, let's put this to be on custom. And now the collision enabled, we're gonna change it from query only no physics collision to collision enabled query and physics. This is necessary for ragdoll to properly work. It's basically just enabling the collision for the whole mesh. So with that said, now we can go ahead and continue. And for our assassination, ragdoll, the only thing that we have left to do is to get our character movement component and just basically set the movement mode to be none to make sure that our AI enemy, in this case it will only be the dummy, will not move anymore. Okay, with that said, we can compile and save, go back to our takedown and call our ragdoll takedown ragdoll. So that will go ahead and happen. And now one of the last things that we have to do is go ahead and pass all of the parameters. In this case, we want to get our reference pose that we got over here, and then just go ahead and get the world location and plug that as the ref pose value. And then about the rotation, well, we just want to get the whole actor rotation. so where our dummy is right now looking at. And now can I take them? Well, that will be the same as we got on our variable over here. With that said, everything is correctly set up. So now our dummy has all of its logic that it needs. So now one thing that we have left to do is to apply the duration over here, which is where we want our character, in this case our dummy, to ragdoll, which will be when the animation has finished and, you know, he's already dead, KO. So let's go and find our animation. Well, we can just go into our takedown and just click this browse icon. This will take us into the animation asset. So now if we double click on it, we can go ahead and preview the animation and we can see the seconds and so on. And I think the right over maybe at, you know, 1.27, which is right at the end, as you can see, by 26. The next thing is 27. I think that's where we're gonna go ahead and just ragdoll our character. As you can see, this animation is properly built to ragdoll. As you can see, it ends kind of when it's falling. That's when we enable ragdoll, so we just fall with physics. So it will look very cool and realistic. So now we can just go ahead and let's put, you know, 1.27, which is what we want to go ahead and wait for that. Now let's do one more extra thing, okay? And it's just enable a small widget that will basically just preview and see, say, take down enemy or whatever you want. So for that, we will need to create a quick UI. So let's create a new folder for it. Just right click and just create a new folder, UI. Let's enter in this folder and now we can just right click, go down and create a user interface. In this case, it will be a widget blueprint, okay? A widget will allow us to place, you know, buttons, text and icons and whatever we want in our screen. Let's create a normal user widget and let's call this WB underscore, and in this case it will be the take down prompt. Let's open this up. So this will be the UI of what it will be appearing on the screen, where our player is inside of our takedown radius and we can click E to go ahead and, you know, take down our enemy. So let's go ahead and go into the palette and search for a canvas panel and drag it into our hierarchy. So now we have this screen where we can place things. In this case, we're going to keep it simple. Just drag a text into our canvas, doesn't matter where, but we're going to go ahead and just change the anchor to be at the center. And then we want to put our position X and Y at 0, so we'll be perfectly at the center, and then change the alignment to be at 0.5 and 0.5. So you can see that moved, and the offset on center of our text to be exactly at the center, which is what we want. Now we can just take the text and just put, for example, this brackets with an E, and then just go ahead and just put, for example, take down, and that's really it. Let's go ahead and just make this a bit bigger so we can change the size on X, as you can see, and also maybe a bit of the font. So maybe we could put this to be maybe at 30, and now also just change a bit the size X and a bit the Y. Just change this bit. You can see it's quite little in the screen, but that's what we want to appear for our dummy. So now we can go back to our dummy, go back to the capsule component, just add a widget. It will be just this widget. And now we're gonna go ahead and put take down, if I know how to, you know, type, take down prompt widget. And now we can go ahead and select the widget class. In this case, the widget class will be the one that we have just created, the takedown prompt. As you can see, it appears here. Now what I like to do is go ahead and change it to be a bit more back and up. As you can see, our player will preview from here, but change the space from bold to screen. And you will not see it, but it will be always locked on and looking at our player with the same size because it's in the screen space. So you will see what I mean with that in a second. If I now press play, as you can see, that takedown is always there, locked on, as you can see, and that looks very good. Now, a thing that I like to do is add a bit of an outline, so we can select our text, go down, and just add a bit of outline. Let's put, for example, I don't know, 5. That was maybe too much, 3. I think that 3 will do the trick, and yeah, that looks perfect. So now we want to only enable and disable this when our player enters. So let's go to dummy, select our takedown radius, go down, and then go into the onComponent begin overlap, which is when something enters in this trigger. So here's the challenge. On the begin overlap, if the actor entering is the player, well, just activate the widget. you can use the set visibility node on the widget component that we just added and just turn to true or false. So just pause the video, give it a go. It should be fairly simple, and we'll cover this in a second. So I'm gonna check that the other actor, which is the actor that has entered in this trigger, has the tag player, which will mean that indeed it is our player. If so, we want to make a branch and go ahead and continue, and we'll go ahead and get the takedown widget and then set the visibility to be true because we want to go ahead and enable this. Great, so with that said, we want to do the same but the opposite when our player exits our trigger. So let's select our takedown radius, go down a component and overlap. Let's add one over here. Just go ahead and just copy all of this, paste it. It will be the same logic that, checking for our player and then accessing our, widget and disabling new visibility because it will not be visible anymore. Now make sure to go ahead and connect other actor into the target, and that's it. Now by default, let's also select the takedown widget and set visible to be disabled because at the start of the game we will not be inside of the trigger. So now when I enter, takedown appears. When I exit, takedown disappears. So that means that I can interact with him or not, which looks very, very, very cool. As you can see, our player already has our player tag assigned that we did in some other episodes. So everything is go ahead and correctly set up. So that's it for this lecture. See ya in the next one. In this lecture, we'll set up the player takedown logic so we can eliminate our dummy. So let's get started. Alright, so let's enter in our player blueprint. So let's enter a blueprints folder and open up our BP wrapper. So in here, as you can see, we already have an input action. So when we press the E key, so let's go ahead and reuse this too. So let's go ahead and just select all of this and move it down. And this logic was, when we press E, so we can interact with objects. For example, our lever that we had over here, which we did in a previous lecture. So what we need to do is go and just add this sequence node, which we'll just go ahead and execute this first, and then this, etc. So we can have different pins from just one node, which is very, very nice. So in this case, what I want to do here is pretty much the same thing. I want to loop through all of the objects that my player is right now colliding. And this is the same idea because for our dummy, if I go ahead and open this up, you can see that we have our takedown radius. So if my player is inside this radius, it is colliding our, dummy with our player. So it will detect it in this node, okay? Because we're getting the overlapping actors. Now make sure that the collision preset for our takedown radius is set as overlap or dynamic. Great, so if so, we're gonna go ahead and just say does implement interface. So in this case, it will be the guard. So if so, it is a dummy or an enemy AI in the future. So we want to go ahead and take down him. In this case, let's go ahead and just continue. And now what we want to do is just call the take down interface. So let's go ahead and just put it on true. There we go. So now basically we will only continue if can take down is true. So let's make a branch just to make sure. So if we can take down that pawn, which is that specific enemy, in that case, what we want to do is play an animation montage. So let's say play montage. In this case, it will not be the play anime montage node, it will be the other one, which is play montage, which will have more outputs as you can see. So in this case, what we want to do is select the takedown attacker montage. Around we are in our player perspective, and we need to plug in our mesh, which this case will be just the only one that we have over here. So that will be our mesh. Great. So now what we want to do is add the motion plugin component into our player so we can take use of motion warping, which, as you may remember, we added it into our animation montages. So we can just go ahead and search for motion warping. Here it is. Press enter. We don't have to change anything of this. And now we can go ahead and just drag it in. And you say add or update warp target. So this will be basically going ahead and you're setting some values for our warping target. let's go ahead and use right click and split this. So we have all the information here. So first of all, our warp target name. As you can see, if I open the takedown attacker and select the motion warping, you can see that this is the name, takedown. So let's go ahead and just copy and paste this. Why do I copy and paste it instead of typing? Well, this is because it has to be exactly the same. If not, it would just not work. Even if you have one small space that you might not see, it will break. So you have to, type it exactly the same. So it's easier to, copy and paste. So now we have to pass some values that it will, go ahead and rotate, translate, and so on. In this case, the target location will be the one that we receive from our dummy, which will be the reference pose. The same with our rotation. And then the rest can be left as not, just default, okay? With that said, we only have one more thing to do. And the problem with this is that our player, when it's very near to our enemy, it might collide. So things might break a bit. And actually, we can go ahead and just preview this for a bit. So if I go here and press E, it will do all this stuff, but kind of just break. And you can see that it didn't even play properly the animation and so on. And it was a lot of separation. So let's go into rubber. And what we need to do is basically use this handy node, which is the ignore actor when moving. Okay, in this case, we're going to go ahead and just plug in our mesh into target and also our capsule component. So both of them. In this case, this is the thing that we want to ignore. And also we want to ignore the whole actor, which is going to be the one over here. So that was what I was saying before about adding a new output, which I said, no, let's leave it for the future. So now let's go ahead and add it. So what we need to do is go ahead and just open up our interface for our guard, and now select this, go back down, add a new output, and this will be actor. In this case, let's go ahead and just put actor, and now we can just put this to be actor object reference. So that will be just our specific pawn that is in their scene. In this case, we can just go ahead and just drag it in and ignore that, and then should ignore true. So the collisions between our player and our victim will be disabled, which is exactly what we want over there. Great, so with that said, let's go ahead and test this out once again. As you can see, our player moves into point, but then no animation is being played. Why is that? Well, that's because we have to add some specific nodes into our animation blueprint so we are able to play some montages. So let's go into our character, rubber. Let's open up ABP rubber. In this case, let's go into our main and graph. And now what we need to do is add the default slot. In this slot is where all of the animation montages animations will play. That's why before they didn't play, because they didn't have this specific slot. As you can see, by default, this slot is the default, which is the one that we need to add over here. It is just built like this. But for example, in the future, if you want to have your animation montages more organized, you could create another slot. For example, one specifically for takedowns, and then you can add the takedown slot, and all of the animation montages will play in that specific slot. But for the purpose of this course, I don't think it's necessary. Okay, so now we need to do exactly the same for our dummy, but in this case, we temporarily just have added the same ABP wrapper, so we don't have to, add it too, because it has the same animation blueprint. So now we can now preview this. You can see it will happen and then ragdoll into the ground, and it looks great, as you can see. But one thing that we have to disable is the E key. We don't need it anymore. So let's select our dummy. Let's open this up with Ctrl E, and basically when we take down, before passing all of the information, we will need to do is get our takedown widget, and then go ahead and then set visibility to be disabled. And then also I'm gonna go ahead and just put this over here, plug this in. There we go. And now we will also only continue if our dummy is not dead. So let's go ahead and just put dead, and now let's go ahead and just put an AND node over here. So if this is true and dead is not boolean, so it is not true, it will not activate our dummy. In this case, for this, because it's disabling, I don't need to add the logic over here, because if it's gonna disable it, we don't need to do a double check, because that's what we want, to disable it. So now our takedown, what we need to do is go ahead and use set dead to be true right at the end. So with that said, we can now press play, go into our dummy, press E, it will automatically snap with the motion warping, and the prompt will disable, and he will just play the victim animation and ragdoll into the floor, as you can see. Really cool. Let's go ahead and just play again, because it looks so cool. As you can see, if I am looking slightly into the right with motion warping, it will go ahead and boom, snap and look into our victim, and then go ahead and just take down him like a pro. So that's it with this lecture. See ya in the next one. In this lecture, we'll set up a dummy, so later we can practice our stealth takedowns with him. So let's get started. Alright, so what we need to do is create a new blueprint for our dummy. So let's go into our blueprint folder, just right click, and let's create a new blueprint class. In this case, we want a character class, so let's go ahead and select it. This will already contain a capsule collider, a character movement component, and also a skeletal mesh. So it's perfect for us. Let's go ahead and select this, name this pp_dummy. Let's hit enter and open this up. Okay, as you can see, it will already contain some things that we require. So here's today's challenge. You need to set up the skeletal mesh for our dummy. For example, using Manny or Quinn, whatever you prefer. But we have done this in the past for our BP router, which is our player, so this should be very easy for you. So go ahead, give it a go, and in some seconds, we'll go ahead and review it. So let's set up a mesh for it. So let's select our skeletal mesh, go down into the skeletal mesh asset, and let's, for example, just go ahead and select SKM Manny Simple. Of course, you can put Queen if you want, it doesn't really matter, it's the same thing. So now in location, let's put -89, this will just lower a bit down, and then in the rotation, in the Z-axis, -90. So he will be looking forward, as you can see with this main arrow of the whole character class. So that's it. Now what we need to do is go ahead and just put our animation blueprint. I'm gonna go ahead and just put to be a BP wrapper. Okay, so we just have the idle animation just for now. Okay, with that said, we can go ahead and compile and save. Now what we need to do into this dummy right now is add a specific radius where our player will enter, and if it's inside, we will be able to basically click E and then assassinate or take down our dummy. So that's what we need to do. So let's select our capsule component, add, and it's going to be a collision. In this case will be a sphere collision, and this will be our takedown radius. Now what we need to do is gonna go ahead and just push it a bit back, so I guess that -40 will do good for me. And then also the sphere radius, I guess that maybe around 50 will be perfect. You can see if a player enters in this area, well, basically we will be able to take down our dummy. So that's great. We can now compile and save. Let's go ahead, drag our dummy into our level like so, and now we will be able to take down him in the future when we go ahead and set up all of the logic for it, which we'll do in the next few lectures. Now let's quickly just go ahead and disable the capsule collider vision for our player. So let's enter in our BP rubber, go into the capsule component, and just search hidden in game, and then let's go ahead and tick this. We just got this left from the last lecture, so now you can see we don't have that outline around the player. Great, so that's it for this lecture. See you in the next one.